Let's conclude this introductory week about Internet and all the different aspects we want to discuss in our OpenHPI course about Internet working. Let's conclude this week with some information and some consideration of security in computer networks, security in the Internet. It is a very important topic, so we plan to have a separate OpenHPI workshop, OpenHPI course dealing with security questions. But here in this learning video, I want to give an overview about important aspects of security. So the various aspects of security play, of course, an essential and decisive role when we use computer networks. They decide whether we can use computer networks and how we can use this and what we should do to use the networks in a reasonable way. That means to guarantee secure communication. We have to start to see that there are two different types of networks. On the one side, there are the closed networks. Closed networks are autonomous islands. In the world, there is no connection to the outside world, there is no interconnection with the network. In this island, the Internet working technology, the TCP/IP stack can be used for communication, but it is not part of the worldwide Internet. It is a private network and does not give any access without a physical entrance to the network. In contrast to the closed networks, there are the open networks. And the open networks, they are characterized that they have a connection to the worldwide Internet. So one can gain these networks not only in a physical way, one can also gain this network from outside over the Internet. Of course, this openness has a large price. So open networks are exposed to a huge number of threats. Every day in the newspaper you can see about and can read about. And often these threats come from some small mistakes in the design of the hardware system, of the operating system, of the application, of the Internet protocols. And attackers misuse these failures to, at the end, what they want to get is access to your data, is access to your identity. Let's have only a very short view on what kind of threats we can observe in the communication networks. To see this, we have here our sender and we have here the receiver, so Alice and Bob. And there is a communication. So Alice sent an information, for example, an email to Bob. And what they use is a worldwide open Internet. And in this Internet, in this shared infrastructure, many people have access, also the attackers and criminals and secret services. All they have access, and everyone who has the technical means can read such an email, send it from A to B, if no encryption is used. But it's not only that the information got lost and that third-party people get insight into your communication. It is also possible that the attacker, the forger, manipulates the email sent from A to B. If the email is sent unencrypted, and if in the Internet there are some changes done, for example, the bank account number of Alice is changed by the bank account number of the forger, of the criminal person, then the integrity got lost. The receiver, Beeb, is no more able to see, is the mail I got, is this the mail exactly which are sent by Alice, or is it a mail which was forged during the transport. There is the possibility by criminal persons also to change the sender address. For example, when we speak about the email. So the information that's transported over the open network is manipulated in a way that the identity is going lost. There is a possibility to get insight into very private information. So an eavesdropper can see and can control all kind of communication. And if there are no security measures taken, like encryption, then a third party can easily see in all the messages which are sent from Alice to Bob. But if we look to, for example, e-business, then there is another possibility that, for example, Alice now is someone who is ordering and Bob has an online shop. So Alice is asked Bob to send her, she wants to buy this and this and this. And then Bob organizes that Alice can get this goods. And then when Bob say, now you receive the goods you have ordered, please pay, then it's possible that Alice says, I never had ordered something. So the question is, can Bob prove that Alice has ordered something? So also the reputation can go away. And finally, there is a possibility, that's only a few examples of attacks, that forgery disturb the network communication at all. That they perform some tasks that took so much load that the mail or the information, the messages sent from A to B cannot come in time or cannot come in a correct way. This is the famous denial of service attacks. So this is only to give you a clue of what is happening in open networks and why we need security measures. To analyze the different threats is important to see that on the very different levels attacks are possible. So when one is thinking about how to secure the network, how to secure his own communication, then one has to define security goals. For example, a security goal is privacy. Nobody unauthorized should know about our communication. If anyone tries to eavesdrop all the communication, then this is an attack, a threat against privacy. Another security goal is to secure the authenticity of a sender. So a threat here is that from the pretense of a false sender, so spoofing is a famous attack where, due to a weakness of the internet protocols, the attacker changed the sender address by its own address. For example, to misuse an internal address from its external position. Another security goal is integrity. That means to guarantee that the information is not changed during the transport through the internet, and threats against integrity are, for example, falsification during transmission. There are more security goals. For example, non-repudiation. A threat here is that a non-legally binding data transmission for using e-business or other communication. So you can imagine there are many, many security goals. These are important ones. And when we think how to implement such security goals, how to guarantee that a security goal remains valid, that our information sent over the open network is not attacked in any one of this case, we have to find ways to secure this. Typically, the availability is not considered to be a security goal, but also the availability is, of course, a security goal. For example, if there is a medical service provided and one can, in case of a catastrophe, not reach the service, then this is a problem. Threats against availability are the famous denial of service, the DOS attacks. When we look to attacks, we have to distinguish between two different attacks. There are, on the one side, the family of the active attacks. Here, the attacker does something. The attacker falsifies contents. The attacker manipulates authenticity. The attacker overloads the network and other things. And beside of the active, we have the passive attacks. Here, the attacker is doing something which cannot be detected from our zone. So he is eavesdropping the communication, spies out the network, records communication of other person, but he is not actively doing something. So of course, due to this characteristic, the active attackers are easier to detect than the passive one, because the passive are doing nothing. The active, they do something. They become active in the network. So by means of security methods, one can much more easily detect the active attacks than the passive ones. Now, what are means to secure communication in open networks and communication in networks? And there is there are science, the cryptography, which provides a lot of methods and tools to secure information in open networks. So cryptography is a mathematical science for encryption of messages. So we have our message that is in clear text telling Bob that Alice wants to meet him and wants to make him a present or other things. This is so-called plain text. And by means of encryption methods, the clear text, the plain text, is transformed into a ciphertext. And the ciphertext looks very stupid. No content can be read. It looks like probable sequence of letters or others. So it's no more possible to detect the content, the original content of this matter. Of course, what is important is that the receiver can retransform, can decrypt the ciphertext back into the plain text. Otherwise, this would not make sense. The ciphertext is only for the transport in the open network, so that nobody, then the sender and the receiver, can get insight into the content of the message. The encryption methods is typically used in a way together with the secret information, the so-called key, which is selected from an astronomical amount of similar information. And by means of this key, is something like a parameter, the encryption methods can be adjusted in such a way that even if the encryption method is public known, by means of the key, the sender and the receiver can trust that only they can use the method together with this key, so encrypt the content in such a way that nobody else can get insight into this information. Let's have a closer look to these encryption methods. Here we have our plain text. And the plain text is a text that sender A, that Alice, wants to send to Bob. Bob is a receiver on the other side. And Alice wants to send this plain text over the open network. And what she is doing, she is selecting an encryption method. She is selecting a parameter, the key, and then the plain text is transformed into the ciphertext. A ciphertext that looks completely stupid and idiotic. And then the cybertext is transported via the internet to B. It is transported through the open network. Everyone can access, but nobody can understand. Because the only one who can understand is the one who has the key that's necessary and that's needed to decrypt, to change the cybertext back into the plain text. This transformation from the cybertext to the plain text, that's the decryption. And then what Bob receives is the plain text, the original plain text Alice wants to communicate to him. But during the transport through the open network, nobody could see the content. Now the role of the key is important, because on both sides the key is needed. And in the cryptography there are developed two families of such encryption methods. The system for encryption and decryption is called a crypto system. And such a crypto system consists of the encryption method, which is called the cipher. It consists of the secret key that's selected from a huge number of possible other keys. And of course the decryption method, which allows to decrypt the cybertext back into the plain text. The complexity, the effort that is needed for encryption and decryption, that is the crypto complexity. We have two families of such crypto systems and encryption methods. The one are the traditional ones, the symmetric encryption methods. In the case of the symmetric encryption methods, also called a secret key crypto system, the sender and the receiver both have the same secret key. To use such a symmetric crypto system, it is important that the sender and the receiver both have access to the same secret key, otherwise the receiver cannot decrypt the information. Of course, this is difficult if people want to communicate over the internet and do not know each other, do not meet each other, one is sitting on the other part of the world, then they have to find a way to exchange this secret key. And for that reason, for internet application, another type of encryption system was developed. This is the modern asymmetric or public key crypto systems. Here the encryption is performed with different keys. There is a public key that can be easily communicated over the internet, and there's a corresponding private key, and every person only has this private key, and it's never possible, never necessary to exchange this private key. We have no time to go into more details. The asymmetric systems, the public key crypto systems, are much more computational intensive. They are better suited for the communication in internet. But if one wants to exchange, for example, video information, then they are much too computationally extensive. And in that way, what we see in practice, for example, if we see SSL communication, then it is typical a combination of these two methods. So one starts with an asymmetric public key crypto system to exchange the key, which later on is used in a symmetric system. So exactly that what's difficult in the symmetric system when only communication is possible over network, to exchange the key. This can be done by the public key crypto system, and then later for encryption the video information, a symmetric encryption method is used for transportation.